So in 5.4, we are talking about the special cases of systems. All right, we already know how to solve systems. We solved them by graphing, we solved by substitution, we solved by elimination. We're not getting a new method to solving these. We're just looking at those special cases. Because we talked about how solving the system is looking at where two lines are going to cross, right? And that was our solution, was that point, that one point that they had in common where they crossed. That's not always going to be the case. There's not always going to be that one solution. Because if you think about it, if I look at this graph, these two lines are never going to cross, right? So there is no solution here. So there is no solution to this system because those lines are never going to cross. And we know that's because they are parallel. If our lines are parallel, there's going to be no solution.
So if the slope is the same, does that mean it's no solution, like automatically?
Not necessarily, because we're going to look at something else, but you're on the right track. So there's no solution if it's parallel. But what if we're looking at two equations that end up giving us the same exact line? If my two equations end up giving me the same exact line, they're going to have that same slope, but it's not no solution, right? If we think about how many points they have in common, how many points they share, there's going to be an infinite number of solutions to this one. So this one is going to be that IMS, or infinitely many solutions. Okay, when it's the same exact line, then it's going to be infinitely many solutions. When they're parallel, then it's no solution. Okay, so that's what we're looking at. Notice that we said infinitely many. We didn't say all real numbers, because it's not like you can just choose any random number and it's a solution to that one, right? You can't just pick a random point out here and say, yep, that's a solution. The solutions still have to be on that line, but there's an infinite number of them, right? There's a ton of those points that are going to work into both equations. So we can solve these a couple different ways. One of the ways is by looking at just y equals mx plus b, just looking at the equations. Okay, so let me clear it. There we go. So if I'm looking at y equals mx plus b, let's say that I have y is equal to 2x plus 1 and y is equal to 2x minus 5. Well, like Aiden said, right, we have the same slope, which means we know they're going to be parallel. So if they have the same slope, but different intercepts, okay, the same slope, different intercepts, that means they are going to be these two parallel lines. Okay, same slope, different intercept, no solution. Okay, so if you want to write that down, same slope and different intercept means no solution. And this is after we get it into y equals mx plus b, right? The equations have to be in y equals mx plus b for us to tell this. Now, if we have two equations, let's say y is equal to 2x plus 1, and then we have to do some rearranging or we have to do whatever to the second one, and it ends up being the exact same thing. If it ends up being the exact same, so same slope and same intercept, this is the infinitely many solutions. So this is same slope and same intercept. And that gives us that infinitely many solutions. So for that IMS, that's if they are the same exact equation. So that's whether they're in y equals mx plus b or not, right? If you have 4x plus 3y equals 12, and let's say 3y equals 12 minus 4x, right? If we have these two equations, then what I can do is I can rearrange that bottom one or the top one. If I rearrange the bottom one and add 4x, it's going to end up looking the exact same as the top one. right? And if your two equations look the exact same, then it's infinitely many. They're the same line, whether it's y equals mx plus b or not. If they're the same exact equation, it's IMS. Okay. All right, any questions on that? This is one way that we can tell no solution versus IMS. Yeah, feel free to use that chat if you have a question. All right, you can continue to ask questions if you have them. I'm going to move on to the other way that we're going to be able to tell other than putting them in y equals mx plus b. So let's look at the equation negative 2x plus y is equal to 3, and then negative 4x plus 2y is equal to 6. So we're not really going to want to do that last way because that's going to involve us solving both of these for y, right? Like we did in the warm up, but solving for y, getting y by itself, and then seeing if they're the same. That would work, but it's going to be quicker just to solve it like we have the last few days. This is set up great for elimination. Okay, so if we solve this using elimination, I would multiply the top by a negative 2. All right, that's going to make something cancel. And when I multiply the top by a negative 2, watch what happens. That gives me a positive 4x, a negative 2y, and a negative 6. Right, when I multiply that top by a negative 2. So now when I add straight down, the x's cancel, the y's cancel, and those cancel. Everything cancels, which means it's going to be nothing left on the left side and nothing left on the right side. We have 0 is equal to 0. If we have 0 is equal to 0, that's a true statement, right? And we said anytime we end up with a true statement, we've been saying this since chapter 1, anytime we have a true statement, that is going to be infinitely many solutions. If it ends up being a true statement. So if both variables cancel and we're left with a true statement, that's infinitely many solutions. This is going to work whether you use elimination or substitution. It's going to work. I just choose elimination here because it's set up a little bit nicer for it. We'll look at one in a little bit where it's maybe set up a little bit better for substitution. Maybe substitution is easier. You get to choose with this. All right, you get to choose which method you want to use. All right, let's look at the chat here. Question about yesterday. When you plug the variable in for the second, you plug it into the original or the equation after multiplying? It doesn't matter. So you're saying, would we plug it into this one or this one? Really, you could plug it into any of these three. Any of the three equations, you can plug that original number into. It doesn't work here, obviously, because we don't have x is equal to something yet, right? But if we got x is equal to something like we did yesterday, you can plug it into any one of those equations. Okay. All right. Good deal. Let's keep going. So let's look at another one here. Let's say y is equal to negative x plus 3 and 2x plus 2y is equal to 4. So here's our system. And this is what I was talking about, where this one might actually lend itself to be easier using substitution rather than elimination. You could do elimination, you could rearrange this and then multiply and then add. But this is, I said yesterday that I use elimination 95% of the time. This is that 5 to 10% where I'm going to use substitution because it's already solved for y. I can take that and plug it in for the other y. Okay, if I do that, it's going to give me 2x plus 2 parentheses, negative x plus 3 is equal to 4. And now I simplify, right? I distribute that 2. That's going to give me a negative 2x minus 6 is equal to 4. 2x minus 2x, I know that cancels out. So I'm left with negative 6 is equal to 4. Negative 6 isn't equal to 4, and we know that. That's a no solution. That's a false statement, so it's no solution. for that one. Let me show you how that looks using elimination. Okay, let's say we wanted to use elimination for that. Rewrite the system here. First thing we would want to do is to rearrange the top. I would add x to both sides. You could rearrange the bottom as well. I think it's easier with smaller numbers. So I'm going to add the x over on the top. That would give me y is equal to, or sorry, that's not it. If I add that x over, now I have x plus y is equal to 3. So now I would have to multiply the bottom by something. So now this is where that extra step is, right? I rearrange, now I got to multiply. It's taking us a little bit more than the substitution to get that negative 2x minus 2y is equal to negative 6. Now when I look at it, those cancel. I have 0 is equal to negative 2. It's still no solution, okay? So either way that you do this, we're going to end up with a false statement. We're going to end up with no solution, okay? All right, from the chat it says, wouldn't you do plus 6, not minus 6 in the distribution? Yeah, you're right. It is a plus 6. You're right, good catch. Yep, it's still no solution, so I got lucky on that one, right? Even if I make a small mistake, but that's a great catch. Good job. All right, any questions about our process here before I give you one to try on your own? Nope. All right, so let's find one here. Let's see. Let's go with this one. I want you to do this one on your own here. We're going to have 4x plus 3y is equal to 27. And I'm going to have, let's see, 4x is equal to 3y minus 27. So figure out how you're going to solve this one, whether it's substitution or elimination. And go ahead and solve that one. Once you get an answer, go ahead and put it in the chat. Let's see if we agree. Now, just as a word of warning, we're not going to know for sure that it's one of these special cases unless we solve it out, right? It doesn't have to be one of the special cases. We could actually get an answer for something like this. So we got to actually solve it out here. I'm assuming we're using elimination here. Elimination is the right choice. Otherwise, we're going to deal with a bunch of fractions. Once we line that up, right? Once we line it up, if we subtract that 3y over, we can add straight down now. And the 3y and the negative 3y are going to cancel, but 4x and 4x are not going to cancel here, right? Once they're both positive. And if they're both positive, we simply have to add those together. 27 minus 27, yeah, that's going to cancel. So I have 8x is equal to 0, which means x is 0. Right? We can't just say, oh, they've got the same numbers. They both have a 4, they both have a 3, they both have a 27, and say that it's IMS. We have to solve it out. We have to see, do they actually cancel? Because here the y's cancel, the x's don't. So we end up with x is 0. We plug that back in. right? 4 times 0 plus 3y is equal to 27, which means y has to be 9. I see that answer from a bunch of you guys. 0, 9 would be our solution. So just because we're in this section, this is good practice, because on the quiz, on the test, it's not going to say this is a special case. It's going to say solve this system. Sometimes it'll be special case. Most of the time, we're going to get an answer just like this. Okay, let's try one more. Let's do one more here. Let's go. Oh, I don't want to make it too easy, right? Nobody wants an easy problem. I guess we'll go with this one. Get that, and then negative 3x equals 4 minus y. Go ahead, solve that out. If you're going to use elimination, make sure everything's lined up first. Seeing a couple different answers in the chat here. Oh, we're kind of split here between no solution and IMS. Let's take a look. Okay, you see it here. I added y to the left side so that I could get everything lined up. So I had negative 3x plus y is equal to 4. To make things eliminate, I had to multiply by 5. So I multiplied everything by 5 to get it here. So I'm now looking at the top equation and the bottom equation as my system. When I add straight down, 15x minus 15x, negative 5y plus 5y, negative 20 plus 20, everything cancels. I've got 0 is equal to 0. This is IMS for that. You got to make sure of your positive negatives. Okay, make sure you see, you got to multiply everything by that 5. You got to make sure everything, or adding straight down, everything's going to cancel on this one. Okay, you got to be careful of that. All right, any questions on this section? So we had two different ways of doing this, right? We had either solving using substitution or elimination, right? Or we looked at y equals mx plus b. Okay, if we look at y equals mx plus b, that's going to give us enough to say whether it's the same slope, different intercept, same slope, right? But if it's not a special case, then moving it over into y equals mx plus b is just extra work, right? So if on that last example where we had the answer 0, 9, if we had put both into y equals mx plus b just to see if they had the same slope, same intercept, they would have different slopes, and then we're stuck still solving it using substitution or elimination. So unless you can see it right away using y equals mx plus b, use substitution, use elimination to be able to get it. All right, let's see the question. I multiplied it by -5. Is that okay? If you multiply by -5, that would give you a positive 15 here, a -5, and a -20. Then you would be able to see that the two equations are the same, right? But they're not going to cancel when you go down. They're going to look the same, in which case we can still say IMS, right? So it's a different approach to it, but as long as you can tell that it's IMS, then that's okay. All right. Good. So